my math YouTube channel. So far we have already covered a lot of these different techniques and methods of evaluating integrals. Guys, now I'm starting doing some challenge problems. These are fun and exciting for me, and I hope you find them exciting and challenging as well. Guys, we already did one of those challenging problems. This is number 2. So let us look at this particular example. So just by looking at this example, we can see that there's no direct ways or simpler ways of just evaluating this integral. Then I think about the idea, because it's a rational function, so how about if I use a partial fraction method? Again, there's no go with that as well, because we cannot write the factors in the way that they are supposed to be, and so we cannot use partial fraction decomposition, and we cannot use any simpler, easier, or straight methods. So then, guys, that made me think about the substitution method, and that's like, for me, that's always a to-go method, like go-to method, kind of like when other methods do not work. So in this case, like, I had few options. Either I could start by substituting the whole denominator as a new variable u, or I can choose one of those and start with that. So guys, what I decided to do is I started with this substitution. So I decided to use u equals to e to the x, right? I started with that substitution. Guys, I'm going to show you all the work, how it works out all well when I start with this substitution. Of course, there's other things and techniques and steps that are involved here. But guys, I would encourage you guys to also try starting with e to the negative x as a substitution step for you, and see if you get the same answer, or if that helps to simplify this and it helps you to kind of evaluate this integral. So that is something that you should try on your own. But I started with e to the x, and it just worked out for me. Okay, so guys, sometimes if you cannot see exactly what is going to happen, but you just start with something which kind of makes some sense to you, and then give it a try. So I started with this, and things started to work out. So guys, as part of the substitution process, step 1 was starting with the substitution. Then you take the derivative, so du over dx, which is what a nice function, exponential function is. The derivative is the same thing. And from here you solve for dx in terms of the other one. So it is going to be du over e to the x, right? By cross multiplying. So guys, I like to box these two key things, because these are the two things that I need to substitute back in the original function, and then see if it simplifies. So we take this back, substitute back, so I can take it up here. So it is 1 over, guys, e to the x is already u, and then I have plus 4 times e to the negative x. So if e to the x is u, what would be e to the negative x? So guys, here, e to the x is u. I want e to the negative x, so that means I just have to raise it to the power -1, because e to the x to the power -1 is e to the negative x. So if I raise the left hand side by -1, obviously we have to raise the right hand side by -1, so it's u to the -1. What does that mean? That means the e to the negative x in terms of u is just u to the power -1. Let us put it in parentheses. It's a binomial. Then I have to multiply by dx. But what is my dx? dx is du over e to the x, right? E to the x. Guys, almost everything here is in terms of u, and we're integrating with respect to du. So we don't like this x term, right? But we can actually get this in terms of u as well, because look at this original substitution step. E to the x is nothing but u. So I don't have to write an e to the x. I can just simply write u here. Now let us see if this actually helped us to simplify this. In order to do that, what I'm going to do is 1 times du is just du. And guys, this u is multiplied to this binomial. So why not just distribute that u and see what we get? So guys, this u times u will give me u squared, right? U times u is u squared. And then this is going to give me, when I multiply this guy with this, u to the power -1 times u to the power 1 is just u to the power 0, which is just 1. So I will be left with just +4. So it simplifies to something which I think we should be familiar with, u squared plus 4. So guys, from here, again, it is not something that we can directly evaluate the integral for, right? So using this substitution did help us a little bit to convert this exponential function into a more like an simpler function, into like, it looks like an algebraic function, but it is still an exponential, because u is actually e to the power x. But let us see if we can evaluate this using other methods that we have learned. And guys, I should remind you, in our substitution, we talked about this clever substitution using the trig functions. So, and I think I did an example, probably I did an example exactly like this, or something similar to this, when I talked about the substitution using the trig function. So in that case, what we realized was this trig identity, and this identity that actually kind of relates to this denominator, was that what is 1 plus tangent square theta, and 1 plus tangent square theta is secant square theta. And guys, you are expected, one is expected to know the trig identities and algebraic formulas and all those things before one actually starts working on integral calculus, okay? So, but if you don't, then you have to go back and look at the formula sheet, and then you will see this formula. So from this formula, what I realized that if I do the right substitution, of course we did this substitution, but we have to do substitution again. So the right substitution here, which I decided to use, was based on this formula, was let u equals to 2 tangent theta. This is the substitution that is needed. And so there's like 2 substitutions here, but that is something one has to do in order to evaluate this integral. And guys, that is what makes this or qualifies this particular example as a challenging problem. So if I use that, let us see what happens. We have to take the derivative of this now with respect to theta here, which is going to be 2, and the derivative of tangent is secant square theta. I have to solve for du, which is 2 secant square theta d theta. Okay. Why am I solving for du and not d theta? Because guys, I look back and look at this function right here. I want to, now I'm trying to, like, the idea of substitution is to change it from one variable to the other variable. Now I'm changing it from u to a theta. So I have to try to change everything in terms of theta. So when I see this du right here, so that's why I directly solve for du rather than d theta, because then I will be able to write du in terms of the theta and d theta. Okay, so let us take it up here, somewhere right here. Okay, I don't want to lose this step because there's 2 substitutions going on here. So don't forget this guy. This guy is very important because the final answer has to be written in terms of x. So got to preserve this, and we got to preserve this as well. So I'm not going to get rid of these. So guys, from here we go back to this integral, and it's going to become 2 secant square theta d theta divided by u square plus 4. What is u? U is 2 tan theta. So it's 2 tan theta whole square plus 4, right? Guys, that is what that integral simplifies to once I use this substitution and this du. Well, this simplifies, we can simplify this. This equals to, let us see what does this equal to. It's 2 secant square theta d theta. Downstairs, guys, this can be simplified. This is 2 squared, which is 4 tangent square theta. Sorry, tangent square theta plus 4, right? Plus 4. Simplifying this further, everything is consistent in terms of theta. So it is integral to secant square theta d theta divided by, guys, downstairs 4 and 4, I can take that as a common factor, greatest common factor, and inside the parentheses I will have tangent square theta plus 1. Once I see that tangent square theta plus 1, that's a big relief for me because I can now use this identity that is equal to secant square theta. Guys, this comes under the section of trig, using trig formulas or trig identities, and I like to think of this as a clever substitution technique. So guys, 2 and 4 can be simplified as 1/2. I can already take that 1/2 outside. Then I have integral of secant square theta over secant square theta, because tan square theta plus 1 is secant square theta, and then d theta, right? Okay, what's going to happen to these? They're going to cross out. I'm only left with 1, right? So let me get rid of this. Guys, I'm not going to get rid of those boxes, the substitution things, because otherwise I will lose everything. So that's right, that's still there. Let us simplify this. This is 1/2 integral of d theta, because this crosses out at just 1. We don't have to really write that 1. You can write it if you want. It's understood to have a 1 here. So it's 1/2, and integral of d theta is just simply theta. And if I have to write this back in terms of, so one step, one thing at a time. There's 2 things going on here. Guys, this is the final answer, almost the final answer, but the original function. So we are able, by using this substitution, simplifying, which is already gone here, but after this we substituted back, we simplified, then we got to this point. But looking at this integral, again, we could not just do it right away. Then we had to use another substitution. We used another substitution, and finally we were able to evaluate the integral. from this to finally evaluating this integral, which is 1/2 of theta. But we know that the original function is not in terms of u, it is in terms of x, right? So the final answer also should be in terms of x. But we have to use two substitutions to go back to x. The first one is 1/2 theta. Guys, theta from here can be simply evaluated. How can we evaluate this? Let me again quickly remind you. Guys, this guy is u equals to 2 tan theta. To get theta, you have to first divide both sides by 2. So tan theta will be u over 2. But now we need theta by itself. To get theta by itself, we have to apply the inverse function. In this case, we have to apply the inverse of the tangent. So theta would be tangent inverse u over 2. Right? So theta, so it is tangent inverse u over 2. This is still not the final answer, guys. Final answer should be in terms of x. But that is not too difficult, guys. Here, this is same as 1/2 tangent inverse. But what is u in terms of x? U is e to the x. So it is e to the x over 2 plus a constant of integration c. So guys, this is my final answer in terms of x. So yes, there was a lot of steps involved, there was substitution involved, but finally we were able to evaluate this integral. So guys, just follow these steps, try to practice this on your own. If you want to do something fun and interesting and challenge yourself, and then also try and see if you start with this, if that makes it easier or more difficult, or something that we can maybe not do at all. Okay, so guys, this is example 2. I want to show you 3 more challenging problems. So just wait till I go to the next problems in my next videos. Till then, take care. I'll see you next time.